Okay, what we have here is the Mega Happy Sprite source code. I'm going to go ahead and make it. As you can see, it makes two primary components. It makes the source code to Mega Happy Sprite and also makes a library called libgui right over here. Libgui is in the GUI directory. Now, libgui works on this basic structure. You have a group, and inside that group you have different objects. Each object is called whenever the mouse enters its position or a message is sent to it by another object. When it enters its position, it gets sent a message called message in focus. When the mouse gets out of its position, it sends a message called message out focus to all the objects in the group. These are all the messages. We have key down, key up, clear internal 2, reload, tick, destroy, mouse move. Message tick is used for the timer. You can set up a timer to send a particular object a message at regular intervals. This is only used in the load and save dialog where you have a blinking cursor. In standard dialog.c, we have various objects that we can make. Objects are usually start with the keyword proc underscore. We have a knob, icon buttons, move button. This is a special button that moves the position of the group when it's clicked and dragged. Okay, this is our file where main resides. Main is right here. As you can see, it checks arguments. It sets up the windows, that is, sets up the positions of all the objects in the main group. Sets up the cursors. Sets up the undo state, sets up the overlay, renders one frame of the VDP, and then finally calls group loop main. Group loop is the event loop for a group. When group loop is called, it takes the position of it takes the space, the area that the group is in, and takes an image of what's in the background, plus enough room for a drop shadow. It then casts a drop shadow and starts drawing the group. The first message that a group typically gets is the start message, which you can see right here by calling the function broadcast group, which sends a message to all the objects in a group. I'll show you an example of a start. Proc info. You can see the first thing it does is it mallocs enough space for, actually way more than enough space for text. And then it prints this text into the two pointers, specified in the object param structure. Param is how many parameters, is all the parameters that a structure can have. There are things called data pointers, data pointer 1, data pointer 2, data pointer 3, just decimal 1, decimal 2, foreground color, X, Y position. There's also width, height, and various other parameters that an object can have. So let's load up Mega real quick. The first thing it does is set up the background as a proc bitmap with back_xpm, which is included in the main file mega.c. You can see all the pictures are included here. They're all XPMs. So the first thing it does is draw the background, then it draws the boxes behind all the tools here and everything else. Then it draws the individual tools. VDP includes all the source code to emulate the VDP. We can draw a pattern. Collapse. This is the function, the main function used to get rid of redundant sprites. It collapses the sprites. This renders the VDP when it's in sprite mode. This isn't a real VDP rendering, but rather it's the sprite editor VDP rendering. You can see what it does is it takes the sprite width and sprite height and loops both X and Y in sprite order, which is reversed. You have X looping on the outer loop and Y in the inner loop, which is kind of weird. And then it computes the inner and outer loop for regular, if you looped it regularly with DST X and DST Y. If it gets a pixel of the current pattern, sticks it in the buffer, and that's it. This is render VDP. This is the main VDP renderer. I haven't actually seen this code in a while, so looking over it's just a reminder of what it does. All this code is very old, but it first renders the background planes, and then renders, well, it just renders the background planes, then renders the high priority background planes using various functions like get pics special, put pics. Put pics puts a pixel into a particular pattern given an X and Y coordinate. Get pics special does something similar to get pics, where it gets a pixel instead of puts a pixel. This is the flood fill algorithm, and this is the line algorithm. In GUI draw.c, we have all the basic functions to draw things on the screen, like vertical lines and horizontal lines. So what happens is if you specify a color, the color change proc sends a message to the palette proc and the sprite edit proc and the VRAM edit proc and the canvas proc whenever it changes, so we can update anything that contains that color. Same thing goes for this. When you switch a palette, it updates this, 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 and this by sending the draw message to all the procs, or rather objects, that that draw these. Then updates. So you have draw and update. Draw draws to a buffer. Update copies the buffer to video memory. That way we can have multiple draws, and we can draw things in order, and we can build things up before we actually copy it to the screen to make things look smooth. Load save calls functions specified in the lex file. Load save mega. When we save a mega, it does a lot of printfs. Because mega is human readable, we just printf the background color, we printf the H scroll, we printf the sprite table, and so on and so forth. When we load it, it runs yylex. Yylex goes through the token descriptions. These being token descriptions. Header H scroll is a digit plus a number of spaces, plus a comma perhaps, a digit plus a tail, plus a number of spaces plus a digit plus a tail. Background color is kind of the same thing. Vertical scroll can either be header vertical scroll is screen to cell and then the tail. Tail being anything that is just a line feed or a comment plus a line feed. And we have various things to do when these tokens are encountered, like set up the BDP background color palette and the background color index for the background color as specified in a mega file. Let's see here. I'll show you the various procs. We have update color text. That updates the text and the color. We have change color, just stuff to do when we change a color. You can see we message all these objects when we change a color. Message pattern edit object, message pattern select object, message pattern change object, message preview object, message background color object, and then we do the updates to the video memory. So we have proc scroll size. That's this right here. We have proc info. That's this down here. Proc preview object. This is the biggest one. This is one kloc. That's the canvas. Proc palette change object. That's this, and so forth. And I think that's a good tour of the source code. Thanks for listening, everyone. Bye-bye.